All right, so I think we'll go ahead and get started. So thank you everybody for joining us today. I'm Allison Foster. I'm the president of the National Board of Public Health Examiners, which administers the Certified in Public Health credential. So our book club was formed, it was a little over 3 years ago. We've now got over 1,000 members. And we read and discuss about 6 to 8 books a year on a broad range of topics, from infectious disease to behavioral economics to policy and public health. And periodically, we invite the author of the book that we're reading to speak with us and give us deeper insight into the public health issue that is the topic of the book. In the past, we've spoken to Jim Curran about AIDS, Ali Khan about pandemics, and more recently, Pam Fessler about leprosy colonies. And if you'd like to see a list of the books that we've read recently, you can scroll through the list. If you go to nbpg.org under Stay Certified, and then look for the list under Book Club. So today, if you have any questions, then you can put them in the question function of the Zoom chat. We are going to keep everybody on mute today to prevent any disruptions to the conversation, but we will actively look for your questions during today's presentation. And we are recording today's webinar so that folks can take a look at it later. So without further ado, I'm very pleased to introduce Dr. David Sedlak. So David is the Plato Malus Mamaf, I might have not gotten that quite right, professor in the Department of Civil and Environmental Engineering at UC Berkeley, where he is the co-director of the Berkeley Water Center and the deputy director of the NSF Engineering Research Center for Reinventing the Nation's Urban Water Infrastructure. He's a member of the National Academy of Engineering and the recipient of numerous awards, including the Paul Bush Award for Innovation in Applied Water Quality Research and the Clark Prize for Excellence in Water Research. And of course, he is the author of the book we're talking about today, Water 4.0, The Past, Present, and Future of the World's Most Vital Resource. So I'm very happy to introduce David. And so what we're going to do is have him start with a brief presentation that gives you an overview of his book. And then we are going to open it up to questions. So David, please go right ahead and share your screen.
Great. Well, thank you very much, Allison. Thank you, everyone, for joining us today. I'm going to share my screen here. I think that's there that everyone can see, right, Allison? Yeah. I wanted to make a few remarks before we begin and maybe review the premise of the book a little bit, but also tell you something about what I've been thinking about since I wrote the book. Since I wrote the book almost 10 years ago now, some things have changed, and I've managed to learn some things through, I guess, all the different people I've spoken to after writing the book who've read it. And so I want to share some of that with you. And I also want to tell you a little about what I'm up to now as I reflect on what I learned from writing Water 4.0 and where I think we're going in the future. So I call this the next phase of our urban water journey. So this idea of writing Water 4.0, I'm not a journalist. I'm not a writer. It's not my day job. It's my outside of normal business moment vocations. You see, I'm a researcher who studies water quality. I'm trained as an environmental chemist. I work with a lot of people in the area of public health, and my main interest has been chemical contaminants and their fate and transport in the environment. So most of my time I spend teaching classes on water quality and water chemistry and water treatment, and working with research students in the laboratory using techniques like mass spectrometry and studying all kinds of interesting trace organic chemicals as they move through the urban water cycle. And I got involved in this idea of writing a book because when I started conducting research on potable water recycling, there was a great thirst among members of the public to learn more. And I found the kinds of things that they were able to learn about through newspapers and magazine articles and the occasional television special on it were somewhat superficial. And I realized that that thirst that an educated person would have, the kind of person who would be interested in reading a nonfiction book, would require a little bit of effort. And so during a sabbatical in 2010, I started working on Water 4.0. And at the time that I wrote the book, I didn't have the title in mind. The title came about after the book was finished. And the reason it came about was that the process of studying this idea of how we got where we are with respect to urban water systems taught me that urban water systems tend to function in a very reliable, predictable way that we almost forget about their existence until a crisis arises. And when that crisis arises, that's the time when a change comes. And social scientists often refer to this as the idea of windows of opportunity, when change comes about driven by some sort of large-scale crisis. And so the three crises that I describe from a historical perspective in Water 3.0 set the stage for talking about the crisis and period of change that I saw us going through when I wrote the book. So if you read the book, you saw that the first revolution, Water 1.0, was the idea that gave us the centralized water supply that is at the heart of all of our water systems. So this idea that once you have a large number of people living in a small area, you need some sort of external water supply. So the example that I give in the book is Rome, and the fact that in order to have 1 million people living in Rome, you needed to bring in water from aqueducts, and you needed to move that water around the city. And when you're done with it, you needed to dispose of the water in some way. And that idea of a centralized water supply, which was critical to early Rome, but it was also critical to civilizations in Mesopotamia or in Persia or China or Japan, places where we had a lot of people settling in a small area, came back with a vengeance during the Industrial Revolution. And so during the period of the 1850s through the early 20th century, centralized water systems were built in cities like Berlin and London and New York and Los Angeles. And I trace that history in the first part of Water 4.0. But that success that we had in providing piped water and using steam engines to pressurize it and move it around the cities set the seeds for the second crisis. And that was a public health crisis of the wastes that were coming out of cities. That is, once people had access to piped water, they could not only have running water in their homes and they could take baths, but they also installed toilets. And so that idea of turning a closet into a water closet and avoiding the chamber pot and the outhouse by having a flush toilet led to large quantities of contaminated water flowing into the environment. And quite often that water was the drinking water supply of the next town downstream. And that led to things like cholera and typhoid fever and a whole host of other diseases that people didn't even know were shortening lifespans. And so the innovation that took place in response to that crisis was drinking water treatment. And so the system of sand filtration and chlorination, used either separately or in combination, sometimes chlorination being substituted for by other ways of disinfecting water like ozonation, was a public health miracle, and it led to a large extension in people's lives, and it really was a revolution. So that's really the second revolution in water, Water 2.0. The third revolution in water was wastewater treatment. And sometimes people think about wastewater treatment plants or sewage treatment plants as something that we put in to protect drinking water supplies. But I think I show in the book that actually the idea behind wastewater treatment was more of a response to the ecological crisis that was caused by the release of sewage into surface waters. So we had this piped water in cities. We were able to take surface waters, rivers, lakes that were contaminated with sewage and make them safe to drink by putting them through drinking water treatment plants. But that did nothing to prevent fish kills and nutrients going into water bodies. And so a period from like the 1940s through the late 1960s and early 1970s, we saw a great decline in the quality of waterways, not only in the United States, but in Western Europe and Japan and Australia and other wealthy countries. And that led to public concerns, and those public concerns were also born out of the environmental movement, where people became more aware of things like oil pollution and pesticides like DDT or industrial chemicals like PCBs. And one of the responses in the early 1970s was to invest large amounts of money in wastewater treatment. And so in a period of about 10 years, the United States spent billions of dollars creating modern sewage treatment plants with the goal of making the nation's surface waters fishable and swimmable. And I think for many of us, we experience the benefits of that and see the improvements of water within our cities. And many places, whether it's the Potomac River or the Great Lakes or rivers that flow through towns now, are much cleaner, and people spend time there because of this investment we made in wastewater treatment. And that brings me to Water 4.0, which is the system that I spend some time talking about in the book. And this little schematic maybe gives you just a little bit of a window into some of the things that I talk about in the last part of the book about the fourth revolution in water, or this idea that I'm seeing. And I know that some of you may live in the part of the country that is not facing water scarcity. For example, if you live in the upper Midwest or the Pacific Northwest or the Northeast, you may not hear as much about water scarcity. You might be more concerned about flooding or large storms leading to problems. But in the West and Southwest, in the Southeast of the United States, and in many other parts of the world, we're running into an issue of water scarcity. And one of the responses that's being pursued is this idea of closing the urban water loop by taking the wastewater from our cities and reusing it. So this is the idea of potable water recycling or water reuse, capturing the stormwater that flows in our streets and putting that back into the water supply, and in some cases even building desalination plants to come up with a water supply. And this schematic just gives you the idea of it, and there are several chapters near the end of the book that talk about the directions and give some examples along those lines. If you read the book, you're already familiar with it, and it should be there, and maybe we could have a discussion about it. I wanted to spend a few minutes telling you a little bit about what I've been up to since writing Water 4.0 and give you a little preview of the next book, which I'm this close to finishing now. I'm kind of in the last chapter, and I have to still run through it. And then with the publisher, it takes about a year before it actually shows up on the shelf. So about a year from now, I'm hoping to publish a book that I'm tentatively titling Water for All. And the idea behind Water for All is that Water 4.0 was really a book about water supply, or water for wealthy people who live in cities. And if you look around the world, there are about 1 billion people who are wealthy. They live primarily in North America and Western Europe and Japan, and they're scattered around other parts of the world. And they live in cities that are rich enough to build desalination plants and to build water recycling plants. And when they have a crisis, the kinds of things that I talked about in Water 4.0 are the way they try to get out of that crisis. But there are 5 other crises that we often talk about when we talk about a global water problem. And I wanted to describe those in a little bit more detail and try to understand the interconnections among these different crises and the technological and policy approaches that are going to be instrumental in dealing with them. So in addition to water for the wealthy, there are 2 other classes of water that I think water crises that are important. And I call them water for the many and water for the poor. So you can see this middle picture on the top is a picture of a series of valves being used to pressurize different parts of a water distribution system in a Central American country where the water isn't available. I'm sorry, this is actually in the Philippines, this picture, where the water is only pressurized for part of the day. Most people in the world live in cities where they have access to piped water, but that water isn't safe to drink because they have intermittent pressure and they have inadequate treatment. So that's one crisis that needs to be resolved. And then the other crisis is water for the poor. There's a photo here of a child scooping water out of a water barrel in Mexico City. This happens to be, but there are about 1 billion people in the world who lack access to piped water, and they're facing their own kind of water crisis that's separate and distinct from those other two urban crises. On the bottom, we have 3 other water crises, starting with water for health. You can see a woman here pumping water in Bangladesh, and you may have heard of the problem of arsenic-contaminated groundwater in Bangladesh, where a well-intentioned effort to protect people from pathogens in surface waters led to mass poisoning by the installation of shallow wells that extracted groundwater from arsenic-contaminated systems. And that issue of contamination with arsenic or maybe fluoride and other geogenic contaminants affects close to 500 million people on Earth, and is an issue that they deal with. But there are also questions of water for health that affect wealthy people. For example, most of us have heard about the problem of PFAS in water supplies here in North America. And there are some commonalities between the struggle to remove arsenic from water in places like Bangladesh and the struggle that families have to remove PFAS from drinking water in the US, namely that our water systems aren't very good at removing these kinds of contaminants, especially when people are not getting a centralized water supply, when they're getting water from a well, a private well, or a well that serves a small number of people. The 5th water crisis that I talk about in the new book is water for food. This idea that we may not have enough water to grow food, and in the next 30 years, we can expect that we're going to have to grow as a planet 70% more food to keep up with the demands of growing population and people's increased appetite for meat as they get wealthier. And that's going to put additional stresses on our water supply. And there are a variety of strategies for growing more crops with the water that we have. And here you can see a picture of flood irrigation, which is still in many parts of the world the most common way to irrigate crops. But actually, there are other strategies that are becoming more important, like drip irrigation. And finally, this question of water for ecosystems. So you can see here an inset slide of the Aral Sea in Central Asia, terminal lake, which has essentially disappeared since the year 2000 as its source waters have been diverted for agricultural reasons. And it's really just a footnote, or rather a representation of the many crises that occur because water is either used by people or polluted by people, and it affects ecosystems. And so the premise of the new book is that these 6 crises are really what people refer to when they think about global water crises, and they're being driven by 2 things. The first thing they're being driven by is something called the Great Acceleration, this idea that since the year 1950s, we've had not only a great growth in the world's population, but with that population growth has come increased use of energy and water and increased demands for food that are not done happening yet. And this figure, which is from a famous paper about the Great Acceleration, shows that perhaps in the OECD countries, the Great Acceleration is reaching an inflection point and population growth is slowing. But still in the BRICS, Brazil, Russia, India, China, and South Africa, there's growth. And even more than that, the rest of the world, and especially sub-Saharan Africa, is poised to undergo a period of great growth. And that has to be coupled with the increasing impacts of climate change. So this is Shasta Reservoir in California, shown from, actually, this is a picture from 2015, but it looks about this way right now here in California. And the idea that we're starting to experience the impacts of climate change, where not only temperature change increases, but changes in global circulation patterns are leading to more frequent and more extreme droughts. And these 2 factors, this increased growth through the continuation of the Great Acceleration, and also the increased impacts of climate change are going to stress these water systems that we have. So most of this new book goes into the ways in which we're seeking to make water use more efficient, not only in our cities by engaging in ways of using water more efficiently, but also within agriculture and industrial practices, as well as the strategies for providing water to people in need. And it covers everything from the way in which we design and build dams and reservoirs and exploit groundwater to some of the topics that were touched upon in Water 4.0, like desalination and water recycling. But the book ends, and I decided that I'd try to make the end of the book a little bit more speculative, and it has some of the elements that are in the second to last chapter of Water 4.0, where I talked about what might be coming about in the future, some of the maybe game-changing technologies that are on the horizon. And I'll just briefly run through them to whet your appetite and maybe bring about some conversation. So I'm going to highlight here a few of these ideas that I talk about, and I won't go into any detail, and maybe that'll start some discussions. The first one I call the chapter Stillsuit for a City. So if any of you saw the movie Dune that came out last year, one of the things that intrigued me when I read the book Dune many years ago was this idea that if you lived on a desert planet, you could go down to the surface and recycle all the moisture from your body wearing a still suit. I don't know if you remember the scene where they go down to Arrakis and they're capturing their breath and using it and capturing it in tanks and reusing it over and over again. Well, we can't build a still suit for a person. We can't even build a still suit for an astronaut. We can maybe do it for a space station, but that's too expensive. But we are starting to build still suits for cities. And I go through examples of Singapore and Orange County, California, and Berlin in Germany, and the way in which these cities are actually starting to close the urban water loop, and how that's likely to become more important, not only in wealthy cities, but in lower income cities in the future. I also talk about a related idea of net zero water buildings. You may have heard of net zero energy buildings, this idea that you can put solar panels on the roof of your home and collect enough energy that you don't need any electricity from the grid. Well, researchers are now starting to think about net zero water buildings, where with rainwater collection and in-building recycling, you might call it gray water recycling, we can provide all the water we need for a building without reaching into the centralized water supply system. And we have buildings already built in the United States and some other countries that are about halfway there. And I think the potential is there to start creating 100% net zero water buildings in the future. Obviously, we can't replace all the buildings we already have, but we can start building or rebuilding, especially in places that haven't yet seen this explosive growth that we've had in the Western world as a way to ameliorate some of the impacts of these coming crises. The third breakaway technology that I think is interesting to start thinking about, I call a better salt machine. This is a picture of a condenser and crystallizer system used for treating the brine produced by a desalination system. And the reason that this is important is that once you get away from the sea, the technology of desalination is limited by the ability to dispose of the salts that we produce in the desalination process. And by building machines that can remove salt from water, it may allow us to continue to farm in places where salinization of soils is becoming an issue and exploit an untapped resource of brackish groundwater, which exists under much of the world's cities. The next topic that I talk about in this last section of the book is the idea of running the rivers. This is a picture of the Prado wetlands in Southern California, a constructed wetland system that is used to improve water quality, but it's really just standing in for the fact that now that humanity has taken control over the flow of water down rivers, we now are the masters of the rivers, and we're the ones who run them. And if we could learn to operate these rivers and the land adjacent to them in a way that that conserves water and protects ecosystems, we'll end up with a better outcome. And finally, the book ends with this idea that I call the right things to do. And that's the whole question of, once we have these technologies that allow us to do so much more with water, why aren't we doing it? And why aren't we treating the environment better and providing people with water? And in this section, I talk about the idea of rights, the human right to water, which is some of the basis for spending money on providing people with water who can't afford it otherwise, and the rights of nature to water. This is a picture of Mono Lake in California, where the city of Los Angeles's right to take the source water of Mono Lake was overridden by the right of citizens to enjoy a healthy environment through a legal challenge to the water rights for Los Angeles brought as part of the public trust doctrine. And I talk about some of the legal mechanisms and some of the ethical issues surrounding this idea of sending water or taking care of the environment. And I think those 5 ideas are really kind of the thing that maybe is a little bit new and different from what was in Water 4.0. So I just wanted to preview it for you. I wanted to give a run through of Water 4.0, and then I'm happy to engage in a conversation about both Water 4.0 and some of these new ideas.
Okay, well, thank you. That was fantastic. So last week, we sent out a call to the CPH book club members asking them to send in some questions. So those of you on the webinar today, you're absolutely welcome to submit your own. And I'm going to go ahead and share some of these questions that we already received with David. So the first question that came in was about chlorination. Could you talk a bit about the risks and benefits of chlorination of water?
Sure. Well, so as I mentioned, really, chlorination was one of the 2 parts of the second water revolution of protecting us from pathogens. And so it's important. Certainly water filtration is almost as important or more important in some cases, but chlorination is really important for inactivating viruses and protozoa and bacteria that can cause waterborne disease. But the risks associated with it is that we can cause the formation of disinfection byproducts. And so these disinfection byproducts actually, we're not sure exactly which byproducts are most responsible, but there's epidemiological evidence of increased rates of premature birth and bladder cancer among communities that use chlorine to disinfect their water, especially those communities where there's a lot of dissolved natural organic matter, like that brown stuff you see in water. When there's a lot of that present, you tend to see these statistically significant increases in those health outcomes. And it's been over 40 years that scientists have been trying to figure out exactly which chemicals are responsible. They have a pretty good idea of which ones are responsible, but they typically monitor the trihalomethanes and haloacetic acids, 2 families of chemicals that are often correlated with these chlorine disinfection byproducts. And so it's a balancing act between putting enough chlorine in the water treatment system that you inactivate the pathogens, but not so much that you form high amounts of these disinfection byproducts. And then finally, you often put a little extra chlorine or residual chlorine in the water after it's done with treatment so that it stays clean between the treatment plant and your home. And so it's possible to substitute chlorine disinfection for ozonation. You can disinfect water with ozone. You can disinfect water with ultraviolet light, but most of the time you need to add a little bit of chlorine residual at the end to keep the water microbiologically safe after the treatment process.
Okay, great. Thank you. Let's see, the questions kind of bounce around here. So let me go to something slightly different. So you just talked about desalinization decentralization of water systems. So the question is, how do you envision it growing in the United States as the norm? And how do we get stakeholder support for this idea to build an infrastructure to support this?
Yeah, I have two kind of perspectives on decentralization of water systems and decentralized treatment. The first is that in our rural communities, we already are engaged in decentralized water treatment. So if you live in a really remote location, you have everything operating in your own home. You have your own well, you have your own septic field, you have your own drainage system. But if you live in a small community, you have essentially what is a decentralized water system where one water treatment facility is preparing water for a relatively small number of people and distributing it around. And so there's an imperative to improve it. In much of the country, some of the most significant violations of public health regulations and the biggest risks occur because the person who's operating the decentralized treatment plant is also in charge of the garbage collection and the roads and about 3 or 4 other things in the city. And so making those systems more modular and predictable and effective is an important thing to do to protect public health, especially in rural communities. And with the increasing availability of sensors and cloud computing and wireless actuator systems, we have the possibility to take those types of decentralized systems to the next level. But the real opportunity that I'm seeing for decentralized systems is to use them as hybrids within cities. So I introduced this idea of a net zero water building. Well, these net zero water buildings are going to happen in places that already have a centralized water and wastewater system. By building these independent net zero water systems within a city, they'll have a safety net. So if their water tanks go empty, they can take water from the centralized system. And if they produce residuals like solids or salts or something like that, they can release those to the sewer system, and that will allow them to be more effective and operate for a lower cost. And it will encourage them to grow and spread, much like rooftop solar panels were always supported by the grid behind us. And people put on rooftop solar panels knowing that at night they could get electricity from the rest of the grid. And so in some ways, the decentralized systems that begin to develop in cities as part of a hybrid will allow cities to continue to grow without bringing in more imported water. And it'll also help diversify the water system. Here in California, it also may be a way in which we can bounce back after things like earthquakes or other kinds of water service outages. So that's how I'm seeing it. I'm also seeing these decentralized systems being instrumental to growth in places like Sub-Saharan Africa, South America, and parts of Asia, where cities haven't fully built out, because you can build different nodes, different pieces of decentralized systems. And as a city develops over time, it can fill in and change more with more, I guess, agility than building a centralized system right at the beginning.
Okay, so this is another question. What is your perspective on the inherent conflict between water conservation measures and the business of both public and private drinking water systems?
This is a great question. That really, and I pointed out a little bit in the book that in Water 4.0 that water utilities in some ways are in the business of selling water, and if they incentivize people to reduce water consumption too much, their revenues can go down. And it's much like what's been seen in the power industry too. Electricity service providers, when they encourage you to use less electricity, they're going to collect less revenue. So it is a bit of an inherent conflict, but it's something that needs to be done. And historically, water conservation has been, like, the knob on water conservation has been turned down at about the same rate that the demand for water increases due to population growth. And so I think it's important to have either government regulations forcing a decrease in the amount of water use, or a plan within a water provider to say that we're going to incentivize people to drop their water consumption, and as a result, the rates for water are going to go up. So it's a complex issue how you set rates for water service provision, but we have to remember that the cost of running a water utility are more or less fixed. So it's not like electricity where perhaps it scales almost directly with the amount of electricity consumed. Most of the costs of operating a water system are for the fixed infrastructure associated with the system and the people who work at the water utility. And so when folks use less water, it probably costs just about as much to run the water system. And so the bills, when they're billed on dollars per cubic meter or dollars per gallon, those bills are going to have to go up as conservation sets in.
Okay, that's really interesting. So the next question is about lead. And just so you know, I think it was about a year ago, we read What the Eyes Don't See about the Flint, Michigan lead crisis. And actually spoke to the author about that too. So the question for you is lead in water systems something that we can live with long-term, assuming the pipes are properly treated? And I should say not in the water system, but lead in pipes, assuming the pipes are properly treated to prevent leaching. And has there been any recent discussion about the complete removal of pipes with lead over a certain number of years or decades, or is this something we're just going to live with?
Well, I think, a big change has happened in the time since you read that book, the stimulus, or rather the Infrastructure Act from the federal government came out, and the part that was tied to water had a pretty big allocation of funding to get the lead out of water systems. And so there is going to be a fair amount of spending in the United States in the coming years to get the lead pipes out of the water supply system. But that doesn't assure that the lead is going to come out of premise plumbing. So the difference is that the water utility is normally responsible for the water from the water source all the way to the point where it enters someone's home. But they don't have responsibility for the water that flows into the pipes in your home or in an apartment building or a school. And so we're going to continue to find that there are lead solder and lead components in old water fountains and old pipes, and these are especially problematic in places that don't undergo renovation. So it tends to affect poor communities to a greater degree. And so I think we're going to be stuck with this system of conditioning the water to minimize lead corrosion. And that's really what people were doing in Flint before the Flint crisis. And then it fell apart when the water supply changed and the state took over. And so the long-term issue of getting the last of the lead out of premise plumbing is going to be a long-term effort because housing changes over so slowly. And I think in many ways, we're going to be forced to continue to manage it for decades to come, because the size of the expense and the challenge of getting it out of every last bit of premise plumbing is going to be extreme.
Okay, here's another question. Do you see the increased amounts of drugs and medications in the water as a problem, and are there methods to remove them?
So I've been working with this issue of pharmaceuticals and water supplies for a number of years now. And I guess my main concern has always been the effects of drugs that end up down the sewer and aren't fully removed in the wastewater treatment plant on aquatic ecosystems. So, we have examples of the feminization of fish in rivers that receive wastewater effluent. We have examples of SSRI, selective serotonin reuptake inhibitors, at levels that could be affecting the behavior of fish in rivers. And so that's always been kind of like the first thing that I've been worried about. The second question of whether the trace amounts of drugs in surface waters are posing human health risks in drinking water is a topic that I've tended to pay a little less attention to or be a little less concerned about, not because there's no conceivable case in which it could be a problem, but because there's so many other things that can find their way into tap water that the drugs are just one of many different things. And so, we have pesticides in drinking water, things like atrazine at relatively high levels. We're finding PFAS in water at levels that are thought to be health problems. And when we look at individual drugs and we compare the concentrations that are detected in tap water with the levels that are known to cause or suspected to cause human health effects, they tend to be many orders of magnitude lower. That doesn't mean there won't ever be a case where that could be an issue, but I think I would, if I were going to lose sleep over a chemical in my water supply, it probably wouldn't be the residual amounts of drugs, because most of these drugs have been tested for their impacts on humans, and generally are safe at these super trace levels that find their way back into the water supply.
The next question I think is then sort of the reverse. What do you lose sleep over when it comes to contaminants in the water?
Well, I think that PFAS is certainly the poster child for chemicals that I lose sleep over in the water supply, mainly because the levels that are being detected are close to the levels where the people have studied and are pretty certain that there are human health effects. So PFAS certainly are one, and the more that people sample for PFAS and analyze for PFAS, the more that are found. And so that's certainly one that I lose sleep over. I do have concerns about nitrate in drinking water. We've become acclimated to the presence of nitrate in drinking water because it's so ubiquitous in the world. And I think when we learn public health, we learn about blue baby syndrome and kind of the impacts of nitrate there. But there's an emerging body of literature that suggests there are other effects of nitrate in human health, and I think that's one I keep an eye on. Arsenic is always out there as something. We reached a compromise on allowable levels of arsenic in drinking water, but it's a relatively high risk level. So it's one that we do the best we can, but we accept it because it's a naturally occurring chemical. So those are probably the ones at the top of my list.
Okay. So I'm going to try to stay a little bit on this theme of inputs, and then we're going to change to a set of different questions. So could you talk a little bit about the rationale for garbage disposals? Because that was mentioned fairly briefly in your book, and It seems that putting more organic elements into the water is not doing the water system any good, but I've not heard any movement to get away. There is a lot of composting now. Maybe that's great, but I'd love to hear what you think we should be doing with garbage disposals.
Sure. Well, the garbage disposals came about because there was a time and a place when people were either supposed to burn their trash in the yard or get rid of it some other way. There wasn't garbage pickup. And so the garbage grinder was an innovation that was designed to prevent people from just getting rid of their organic waste without any formal means of composting. And in some communities, you still had pigs running around, rooting around, and you still had animals, and it became an attractor for I presume for rats as well. And so there were concerns about public health from inadequate disposal of garbage. And then I think it evolved to something of a convenience that people didn't have to worry about all this stinky food waste in their garbage can, and you could grind it up and put it down the sink. And in some ways, when you had a sewage treatment plant, the sewage treatment plant was designed to treat that much the way that the landfill was designed to treat it, so people didn't notice. But very quickly, the wastewater treatment plant engineers and the people who operated the sewers were realizing that that loading of organic matter was stressing out their treatment plants and their ability to treat the water, and costing money, because it costs money to bubble oxygen into the water to keep the microbes going that knock off the waste. And so I think that New York City had tried to ban garbage disposals, and there are a few other cities that have kind of overstressed waste collection system where the sewers just can't handle it. And plumbing codes have phased out garbage disposals, but they still seem to be pretty ubiquitous, and they're seen as a modern convenience and one that we don't need. And so certainly composting is great. There are efforts to take that compost and green waste and put it in what are known as digesters, anaerobic digesters, and convert it into methane, essentially natural gas. So for example, my utility, East Bay Mud here in Oakland, actually takes green waste that they collect from restaurants and industrial sources, and turns it into biogas, and uses that biogas to operate the sewage treatment plant. So it seems silly to take this organic waste and put it down the sink and spend energy treating it, especially if we could find a way to either turn it into natural gas at a treatment facility like a biodigester, or at least make household compost out of it. And so both those things seem like better ideas than garbage disposals.
Seems like there's a lot of possibilities. It's just getting public opinion to change is probably one of the biggest challenges.
Well, and in the issue of, I mean, picking up household green waste and turning it into biogas, it's not simple. The utility here struggles with that because they can't put plastics and other kinds of material that doesn't break down in their digesters. And so they're much more likely to take waste from a food processing plant than they are from a restaurant, although they're starting to experiment with ways to get clean streams of green waste coming from commercial sources, and so it's not entirely easy to collect, and so some of it will inevitably end up in the trash in some way or another.
Right. So we're going to turn to sort of bigger picture water availability and use. So we've got a question here. Can you name some countries or cities that are being particularly innovative?
Sure. The Economist magazine did a survey about a year ago, a global survey of water utilities in cities around the world to see which ones were most prepared for climate change and doing the most innovative things. And surprise, surprise, Los Angeles came out #1 out of hundreds of cities that they considered worldwide. And so Los Angeles and Southern California in general has been leading in things like potable water recycling, capturing of stormwater in city streets. And so it's no surprise that many of the examples in Water 4.0 and my newer book come from Los Angeles. Another place which is a leader in innovation that everyone looks to is Singapore, where the island city-state doesn't control its own water supply. Its imported water supply comes from Malaysia, so it's always been a national security concern. And so Singapore has done a very good job with water recycling and capturing rainwater and adopting efficiency. And then of course, Israel is held out by many as really the exemplar of water technology. And so now Israel gets essentially all of their drinking water from seawater desalination, and they send all the used water to their farms for agricultural irrigation. And so, and they also have some of the lowest per capita water use in the world. And so those are probably my three biggest ones. I know you asked for cities, so Tel Aviv's there instead of just Israel as a country.
All right, great. Do you think our water supply is susceptible to bioterrorism? If so, what's one mitigation tactic you would recommend in protecting against bioterror threats?
Well, after 9/11, Homeland Security, I think, gave a deep look at this issue of biosecurity and the water systems. And my take on it was that what I was able to learn about their analysis is that it's not especially vulnerable. That is, you need something that's really, really toxic where you need to figure out exactly how to get it into the water system to make it susceptible. And, it's a bizarre thing to think about, like your society's susceptibility to acts of terror. There are just so many ways to terrorize us, involving poisoning of air and food and everything else. And I'm not sure that the water supply is the easiest one for a terrorist to go after. So a lot of the energy that people put in initially to this question of bioterrorism in the water supply, I think was driven by kind of, this panic you would have about it. But I think once people realized that the water supply had been poisoned, they would obtain water from other sources. They drink bottled water and they'd shut the tap off and flush the thing out. I think where we are probably more vulnerable is to water supply interruption through hacking, like cyber attack, which could turn off our water systems. And certainly there's starting to be an increased recognition of all types of infrastructure that the computer systems that we use to control them need the good security to avoid coming offline. And if they come offline, I think it's not maybe as dramatic a thing to think about, but when a water system is shut down for days on end, that's a fair amount of disruption and suffering that happens.
That's reassuring to some extent.
Well, yeah, I mean, I think talking to people who thought about these things is like, oh, I don't want to have to think about all the different ways that someone could disrupt society. But I kind of concluded that the water one was just one of many different ones.
So we have a couple different questions about what can we as the public health profession do to ensure our resources are safe and plentiful, but also what is we as individuals can do. So I think maybe we could just have you give us some general advice, like I said, as our profession and individuals, how we can really move this forward and make sure that our water resources, continue to be safe.
Well, let me start with as a profession. I think as a profession, I don't know, when I first learned about PFOA, which is the and PFOS, the two PFAS chemicals that have received the most attention, and what happened in West Virginia, I was so surprised that this happened so late on in the game. Like I was aware of the things that had happened with Love Canal and hazardous waste sites in the 1970s and 1980s, but the fact that another set of chemicals caught us flat-foot again and people were exposed to them for such a long time was very distressing to me. So I think as public health professionals, it's on us to be a little bit more active and not complacent, that we know everything about chemicals used in commerce and their possible health effects. And there's a kind of a professional obligation that when we learn about some of these effects, we really need to elevate them to a higher level of concern when it shows up. So I'm not sure exactly how that happens and when it happens, but it certainly, to me, feels like a little bit of a failing. And our inability as public health professionals and engineers to regulate chemicals and to think about their health effects in a more meaningful way, it really does seem to reflect poorly on us as a profession. That we regulate less than 1% of chemicals used in commerce, and the drinking water maximum contaminant list, that is the drinking water the chemicals in drinking water that are subject to regulations, is such a tiny fraction of the chemicals that we might be exposed to. I think it's up to us as a field to kind of find better ways to break through the morass of just allowing things to go out and be used and worrying about them later. So that's kind of from a professional standpoint. From a personal standpoint, it's a little bit hard, and I struggled with it at the end of Water 4.0. It would be very easy to tell you, put a bucket in your shower and collect the water, or don't run the tap while you're brushing your teeth, or whatever else it is. But it's complicated. A lot of our water use is associated with the food we eat. And some of that food is grown in places where that water use has a huge impact on the environment, and other food is grown in places where there's ample amounts of water. So there's not a simple blanket prescription to decrease your water footprint or to make water resources more sustainable. And so in some ways, I think maybe it sounds like a bit of a cop-out, but I think it's really about supporting policies and leadership that's willing to get beyond the slogans and to think more comprehensively about our future sustainability of water and of ecosystems. And so I wish I could give you some simple thing that you could do every day that would make things better, but I really think it's more this process of educating ourselves and being alert and being active in pushing for improvements in our water systems.
Okay, so I'm going to throw one easy one out, and then we're going to start to wrap this up. Are water filters and refrigerators effective and worth the expense?
Oh, yeah, I mean, I think there are a number of reasons why having a water filter for personal use may be worth doing. Whether that's in the refrigerator or it's one of those, in the carafe carbon filters or material filters. They're pretty good at removing chemicals from water. They also remove some of the chemicals that give water off tastes and odors. So if you live somewhere where you have surface water and it tastes a little swampy, an activated carbon filter will do a great job in making the water more palatable. And if you don't like the taste of chlorine, the filter will often break down the chlorine. And so just the contact between the chlorine and the filter will cause it to decompose. The issue with those at-home water filters is you have to change them. They don't last forever. They have a finite lifetime, so you have to keep on top of them. It won't remove absolutely everything, but I think they're not a bad thing, especially if you're concerned about your water.
Great, thank you. All right, so we'd love to hear what you're reading now. Since we are a book club, we're always looking for new ideas.
Oh, well, I hate to disappoint you, those of you who are interested in nonfiction. When I write a book, I usually like swear off of nonfiction while I'm writing a book, because it makes me think like, oh, that person's such a great writer. I could never write like that. So I've been reading a little bit more fiction. So I just finished last night David Mitchell's most recent book, Utopia Avenue. And I've always been a big fan of his work, like the Cloud Atlas. And then before that, I did read a nonfiction book, and it was What I Write About When I Write About Running by Haruki Murakami. And Murakami is one of my favorite authors, and it was nice to see a biography where an author writes about running, because that's my other passion in life.
Oh, it's fantastic. Thank you for sharing. All right, so we're at the end of our time. Thank you so much. This has been absolutely fantastic. I personally loved your book. Can't wait to read the next one. So if you think about it, send us a note, a year or so out,
Okay.
and we will add it back to our list so that everybody knows it's available. And for those of you on the presentation today, we are going to upload this to YouTube so you can share with your CPH colleagues, and anybody that missed it can watch this later. So thank you, everybody. Thank you, David.
Thank you. And if anyone else has questions, my email is just my last name, sedlak@berkeley.edu.
All right. Thank you. Appreciate it. Bye-bye.
Bye, everyone.